Thank you, Mr. Chairman. Good morning, distinguished participants. In this first framing presentation, as the chairperson already pointed out, I will focus on one important dimension of existing inequalities and poverty. And actually, this is one dimension that is visible from space. There are many areas which are still lacking light. So my focus will be on electricity infrastructure. But before I do that, I would like to stress the multidimensionality of the issues that we are talking about this morning. And single-dimensional monetary, money-centric measures of poverty are increasingly giving way to multidimensional indicators and indices. While I will not attempt to give a comprehensive picture of all these multiple dimensions, I would like to start by mentioning just some of the most important ones. So we heard already yesterday about the importance of the social dimension. Many people talked about trusts and norms. And my colleague, Dr. Bayer, will also address this in the next presentation. Capital of all forms is essential: natural, physical, financial, and I will focus on infrastructure of the electricity sector. Human capital was the focus of Professor Lutz's talk yesterday, and of course education, healthcare, and gainful employment are essential. And finally, the institutional dimension is overarching because, of course, good governance underpins progress in all these dimensions. Now, we started by trying to look at inequalities in some important dimensions, and we use this Lorentz curve type graphic to show the inequalities globally. So the diagonal through the center is actually the line of equality. And the further away, the further below the diagonal, the greater the inequality. Now, importantly, the blue and green curves, which are inequalities globally in income and final energy, mirror each other quite strongly. So in other words, about 20% of population earns more than 60% of income today and uses about 60% of final energy. If we look at inequalities in electricity use, these are starker. So about 20% or more of the population today actually uses no electricity because they have no access to electricity. And if we look at how historically electrification has occurred over time, again, we see that in one of the earliest countries to electrify their populations, the United States, this occurred basically over a period of 3 to 4 decades. Many of today's emerging economies started from a lower per capita income level, but also achieved this within a period of 2 to 3 decades. However, of course, there are many developing countries and some larger basic countries like South Africa and India that still have a large proportion of their population still to electrify. So in the case of South Africa, about a quarter, and in the case of India, about a third. One of the lessons we learned from this historical analysis was that in countries where electrification was integrated within wider developmental and poverty alleviation efforts, the successes were greater. Now, we look at the current status of inequalities in access to electricity infrastructure by looking at the installed capacity per capita by nation. And as this map shows, there are some regions that really stand out. Sub-Saharan Africa today has a total installed capacity equivalent to that of Spain's. And of this total, half is in the single nation of South Africa alone. South and Southeast Asia are other regions that stand out. And not surprisingly, these are the two regions where we have the largest concentration of unelectrified population today. Now, in order to look at what solutions we can achieve to electrify the remaining unelectrified, we carried out a detailed analysis of what would be required. And of course, we learned that achieving universal electricity access by 2030 is achievable, looking at these historical trends as well, if we have sustained government commitment, ambitious targets, increased investments, and increased capacity building. However, in addition to that, we also try to analyze how can electrification take place in order to maximize benefits for the poorest of the poor. And in the remaining few minutes that I have in this presentation, I would like to highlight three main insights that we have gleaned from this analysis. The first insight is that regions differ. Now, this seems fairly obvious, but sometimes this is forgotten. And if we focus in on the two areas where we have the lack of access, greatest lack of access, that is sub-Saharan Africa and South Asia, one of the clear things that is visible from this map is that in sub-Saharan Africa, population densities in areas that are unlit are rather low, whereas in South Asia, these are rather high. Clearly, this means solutions may differ. And if we want to look at how these solutions might differ, we can focus in on one sub-Saharan African country, Kenya, as an example. One of our summer students a few years ago did analysis on Kenya, and basically, in her first step, she tried to assess what would be the potential demand or the latent demand in unconnected households by province in Kenya. And as you can see, the darker areas in the southwest and center of Kenya represent areas where there is higher demand today. These are regions also that are already close to existing grids in Kenya. But what we learned from this analysis is that for most of the region of Kenya, about 80% of the gridded area of Kenya, off-grid solar photovoltaic technologies would be a more suitable solution and could immediately provide benefits to about 25% of the population. The second lesson that we learned is that populations are not homogeneous and that they are changing over time. And these heterogeneities and time dynamics matter a lot. So to illustrate this, I take the example of India. Here is a graphic showing you the lighting demand in rural and urban households by expenditure quintile. And what you see is clearly in the poorest rural households, the first 4 quintiles, kerosene dominates lighting demand today because there is no access to electricity. In urban areas, the situation is quite different, and because of electricity access, people use only electricity for lighting. Of course, these 4 population quintile groups in rural areas that comprise about 80% of the population today will be only less than 50% of the population in 2030. So of course, these differences in the paying capacity and incomes of different population groups and their changing demands over time are important inputs for any kind of electrification efforts and planning. The third and last insight that we have gleaned from our analysis is that benefits are multiple and these need to be estimated. We all know that electricity has the potential to transform lives and is essential for all elements of human well-being. While we take a lot of effort in estimating the costs of extending electricity grids, the benefits are harder to estimate and so often receive less attention. But of course, these benefits are important. And I will highlight recent research results that illustrate some of these benefits. One of the benefits is in the form of saved subsidies on existing sources of lighting like kerosene. And in the case of India, over 40% of the rural population today still uses kerosene as their primary source of lighting. Many more use it as a backup fuel. Kerosene is highly subsidized in India, and current subsidies are of the order of $1 billion just on lighting for rural areas. Clearly, universal electrification would save the Indian government between $0.6 to $0.7 billion in saved kerosene subsidies. Another benefit is for the non-farm enterprises. We've seen that when electrification efforts are coupled with income generation activities, these provide the biggest benefits. And in recent research results, we've seen that non-farm enterprises are a big source of employment in India. Electricity access can increase the probability of owning a non-farm enterprise by about 5% and increase earnings by about 25%. Not only is access important, but it also needs to be regular and reliable access. Every additional hour of electricity can increase incomes by about 0.5%. So in concluding, I would just like to highlight that IIASA is at an interesting and exciting phase of research on poverty and equity. This was highlighted for the first time in IIASA's strategic vision in this decade. And we will focus on doing more research in this area in the coming years. Systems analysis can be important in understanding solutions for poverty and equity, and I would like to leave you with two areas that we would like to focus on in the future. One is understanding more deeply what are the multiple dimensions of poverty and equity, how are these interconnected and interrelated, and what are their underlying drivers. And secondly, to try to really understand and estimate the multiple benefits of even single interventions like electrification, which would help us leverage synergies in investments and also inform better coordination across policy domains. Thank you very much for your attention.